Hey everybody, this is Larry. This is day 4 of the February Leetcode Daily Challenge. I created a new haircut, so hit the like button, hit the subscribe button, join me in Discord, let me know what you think about today's problem. So I'm going to try a little bit different today before going to the problem. Okay. Which is that I want to read this thing from Jeff Bezos. And feel free to fast forward or whatever, it's fine. Because I usually record these live, but I also just have something that I found interesting, which is in Amazon's earnings letter or whatever it's called. But I thought that it's relevant to people, working hard on learning the Leetcode and stuff like that, and just algorithm and stuff, which is this part, the perfect handstand. So I'll read it real quick, and again, you can fast forward or skip ahead. But so perfect handstands. I'm gonna do my best Jeff Bezos impression. A close friend recently decided to learn a perfect freestanding handstand. No leaning against a wall, not for just a few seconds. Instagram good. She decided to start her journey by taking a handstand workshop at her yoga studio. She then practiced for a while but wasn't getting the results she wanted. So, she hired a handstand coach. Yes, I know what you're thinking, but evidently, this is an actual thing that exists. In the very first lesson, the coach gave her some wonderful advice. Most people, he said, think that if they work hard, they should be able to master a handstand in about 2 weeks. The reality is that it takes about 6 months of daily practice. If you think you should be able to do it in 2 weeks, you're just going to end up quitting. Unrealistic beliefs on scope, often hidden and undiscussed, kill high standards. To achieve high standards yourself or as a part of a team, you need to form and proactively communicate realistic beliefs on how hard something is going to be. Something this coach understood well. So I think my thoughts, I think y'all are smart, so like you could probably draw the parallel here. But I think I get a lot of questions about how to, what's the short way to learn all these things, and my general answer is there really no shortcuts. Like maybe if you do things in a certain order, like you save a little bit of time, but to be honest, there's no replacement for just working hard and consistently and setting realistic goals and just pace yourself. I always talk about pacing yourself with respect to burning out. So definitely, just do that. And okay. So all that said, let's get started on today's actual problem. Longest harmonious subsequence. We define the maximum. We define a harmonious array where the difference between the maximum value and the minimum value is exactly 1. We turn the length of the longest array. Okay, let's see. I think immediately I'm thinking of a couple of things. And let's see. So the first thing I look at is n is 10 to the 2 to the 10 to the 4th. So you cannot do like n square. At least in Python, it's going to be too slow. Maybe in some other languages, it'll be slightly fast enough because apparently Java is really fast on Leetcode. But if you're practicing for interviews, you probably don't want to do that anyway. It's exactly 1. Okay. I thought it was going to be 1 or smaller, so that's kind of a little bit odd. Maybe not a little bit odd, but just a little bit tricky. Okay. Oh. Did I miss? I think I misread this actually. Give me a second. So I actually misread this as sub-array instead of subsequences. It's very easy to mix them up. But luckily, when I look at the test cases, it clears that up because I was like, oh, isn't there 5 in here? But the answer is no. So I would say if it was a sub-array instead of subsequence, I would be thinking, and I was thinking about something like a mono queue or max queue or a min queue, some variation of that, and try to figure out how to take advantage of it. Maybe dynamic programming with under difference or delta or something like that. I would play around with those ideas, but then as soon as I saw subsequence, then it becomes less important, right? And the thing with subsequence is that there are a couple of things, right? Well, the first thing is that actually, maybe unintuitively, even though it tells you specifically that you can't change or you shouldn't change the order, maybe unintuitively, you can actually change the order, or the order doesn't matter because in this case, you only care about the max element and the min element, right? So what that means is that the order doesn't matter because you can have the two numbers at exactly, in any number of any number of ways, right? So then the second question is, okay, then how do we take advantage of it? Well, the first answer is you could probably sort it. You could sort it and then you do a binary search on the left, on the right, like for every number, you just do a binary search and, try to find the numbers that you can put into this range. Again, the orders don't matter because of the subsequence, so you can kind of do it that way. That'll be n log n for the pre-processing, and then a lot of log n's. But we can actually do this in linear time by just keeping track of the counts, because again, the order doesn't matter. So because the order doesn't matter, we actually don't even care about any, like the numbers are just like, because we can use them in any order, we just have to keep track of the counts of each one. And that's basically what we're going to do. So I'm going to use something like count is equal to collections.counter nums. And I'll explain this really quickly. It's just basically you can look at this as a dictionary between an item and the count. So then you would have like for x in nums, count of x1. I mean, I know that this has to be a default int, or a default ticked with an int, but basically that's what this code does for me. In case you're not, familiar with Python, that's what this code does, or that's what this code does. And then after that, we just have to brute force on the keys, right? Okay, so let's do best is equal to 0. That's the answer that will return. And then just for x in count.keys, if count x plus 1 in count, so we have to make sure that this exists, then best is equal to max of best count of x plus count of x plus 1. So this is just greedy, of course. And then we just return best. This is greedy because now, looking at this example, we have to make sure that the x plus 1 is in count, right? So we look at all the keys. It doesn't even have to be in order, so there's no sorting. Basically, because the difference is exactly 1, all the numbers in this array, that's one observation that I guess I actually forgot to point out, even though I noticed it, that every element in the array has to be exactly x or x plus 1. And both of them has to exist at least once, right? So if this is 1 or less than, then it doesn't have to be. Then I don't have to have this if statement. But because it is exactly 1, they both have to exist. The x and x plus 1 has to be in the array. And it being in the array assumes that this is greater than 0 on both these, count of x is greater than 0 and count of x plus 1 is greater than 0. You could, depending on your language, you can do that check instead. But that's basically the idea, and it's going to be greedy. I'm going to run some tests, or at least finish copy and pasting the rest. And this is greedy for that observation because this is exactly 1. You need all the elements to be x and x plus 1. Oops. Yep, and it looks good. Let me double check the constraints. I think there's no weird edge case. Maybe one number. Let's see. I mean, that would just return 0, so I think it doesn't matter because x plus 1 by default doesn't exist. Okay, so let's give it a submit. Cool. Yeah, I mean, this is pretty straightforward. In implementation, like I don't think I have to explain the implementation that much more. Yeah, let me know if you have any questions. And of course, the complexity is going to be linear time, linear space, because for each number, we will go through this at least n at most once, and then we just do this, this is O of 1. These are O of 1 operation, assuming hash table stuff, which. There's always a nuance of hash tables, but assuming they're O of 1, then this is going to be linear time, linear space, and then that's all I have for this problem. Let me know what you think about this, and I will see you tomorrow. Stay safe, stay healthy, to good health, and yeah, to good mental health, and do well. Bye bye.